Hi students. So 10th class students, welcome to my class. So today I am going to explain you chapter 1 of physics. Okay, so your topic is reflection of light at curved surfaces. So do you know what is reflection means? What is actually reflection means? Throwing back by body. Okay, so reflection means throwing back by body. So in class 7th and 8th, you learned about the image formation in plane mirrors. Okay, so what are the examples of plane mirrors? Yeah, mirrors used in automobiles, torchlights, dentist, solar cookers, shaving mirrors. So these are the example of plane mirrors. You also discussed about the spherical mirrors. You know that why the curved surfaces are known as spherical mirrors. So examples of spherical mirrors are mirrors used in street lights, mirrors used in shops. So you might have got many doubts while observing your image in bulge surfaces. Is the image formed by a bulge surface same as the image formed by a plane mirror? Is it the same? Is the mirror used in automobiles a plane mirror? Why it is showing small images? In automobiles, why is your image is shown small? Why does our image appear thin or bulged out in some mirrors? In some mirrors you can see your image as sometimes thin and sometimes bulged. Okay, what happened to that mirrors? Can we see inverted image in any mirror? Can we focus sunlight at a point using a mirror instead of magnifying glass? Okay, so are the angle of reflection and angle of incidence also equal for reflection by curved surfaces? So are they same? So let us discuss. So we are going to discuss all these things in this chapter. Okay, so let us discuss about the reflection of light by spherical mirrors in this lesson to get clarify for the above questions. Okay, so now reflection of light by spherical mirrors. So what actually reflection means? Bouncing of light rays after hitting a surface. Okay, so when you take a ball, okay, when you take a ball and when you hit a ball to the wall, what will happen? When you take a bouncing ball, you have to take a bouncing ball, what will happen? It will come back to you. Okay, so here's the same thing happen here for reflection of light. Okay, so the light rays, the bouncing of light rays, okay, after hitting a surface, okay, the light come backs to you. Reflection of light by spherical mirrors. Now we are going to learn reflection of light by spherical mirrors. So here we are going to learn the first law of reflection. So what does the first law of reflection tells us? So a light ray incident at an angle with the normal at a point of incidence will get reflected making equal angle with the normal. So this is shown in this diagram. Okay, you can see this diagram here. The light ray incident at an angle, the light ray incident at an angle with the normal at a point of incidence will get reflected making equal angle with the normal. Okay, so now we are going to do the activity 1. Okay, activity 1, what is our activity 1? Finding the normal to a curved surface. So what you have to do in this activity, take a small piece of thin foam or rubber. You have to take a small piece of thin foam. You know what is a foam? We will use foam beds in our home, okay, for sleeping, and we will use this foam in our kitchen for washing utensils. So, or you can take the sole of your slipper also. Okay, so put some pins along a straight line on the foam. It is shown in the figure. You have to put some pins on the foam. So all these pins are perpendicular to the plane of foam. You can see this in the diagram. They are perpendicular to the plane of foam. If the foam is considered as a mirror, so here if the foam is considered as a mirror, we have to consider the foam as a mirror. So each pin would represent the normal at that point. So any ray incident at the point where the pin makes contact with the surface will reflect with the same angle as the incident ray made with the pin normal. Okay, so what happened here? Each pin would represent the normal at a point. They are normal at that point. So any incident ray at the point where the pin makes contact with the surface will reflect. with the same angle as the incident ray. So this is the first law of reflection, okay, made with the pin normal. So now bend the foam piece. What you have to do, you can see this in the figure, okay. You have to bend the piece inwards. You have to bend it inwards, okay. So what happened to the pins if we bend inwards the foam? They still represent the normal at various points, but you will notice that all the pins tend to converge at a point. So here the conversion happens. Converge means they intersect at a point, okay. If we bend inwards this foam, what will happen? The pins tend to converge at a point. So the pins meet at an intersection point, okay, when we bend inwards, okay. If we bend the foam piece outwards, we will see that the pins seem to move away from each other, or in other words, they diverge as shown in the figure. So what will happen if we bend the foam outwards? What will happen? What you will observe? The pins move away, okay. They move away, they diverge, they will get diverge, okay. Converge means they will get intersect. So in this if you bend the foam outwards, what will happen? They will get diverge, okay. So this gives us an idea of what is likely to happen with a spherical mirror, okay. So the same thing happen when we use a spherical mirror, okay. So a concave mirror will be like the rubber sole bent inwards. So we have taken the two foams now. So what happened for the first foam when we bent the foam inwards? So this shows the concave mirror. This is the concave mirror, okay. The rubber sole which bent inwards, it is known as a concave mirror, okay. If we take a mirror instead of foam, if we take a mirror, so and the convex mirror will be like the rubber sole which is bent outwards. You can see this also in the figure, okay. So for concave mirror, like these pins in figure, all normal will converge to towards a point. So all the normals which are converged to a point, which are intersecting at a point, so this point is called the center of curvature of the mirror, okay. So write this in your books. What is the center of curvature means? Or the normals will converge to a point, okay. In a concave mirror, okay, all normals will converge to a point, okay. So this point is called the center of curvature of the mirror, okay. So this is how we have to do this activity 1, okay. So we know so by this activity we know that what is a concave mirror and what is a convex mirror. So more topics are there in this chapter. We are going to do these topics in my next video, okay. If you are having any doubts regarding these topics, please comment me in the comment box, okay. You can write a message for whatever doubts you are having, and I will answer it, okay. Till then, stay safe. Goodbye.